Right. So, first of all, what is a triangle? A triangle is a polygon. And in case you've forgotten what a polygon is a geometric figure made up of segments that enclose an area of space and only intersect at their endpoints. They don't cross in the middle or anything like that. Triangles are classified two ways, by their sides and by their angles. First of all, by their angles. If you have an acute triangle, all three angles have to be acute. If you have a right triangle, it's got one right angle. And what are the other two angles? What kind of angles are the other two?
Acute.
They're acute. Thank you, Peter. Yeah, those other two angles are acute angles. So you have to be careful. People sometimes will say things like, if it's got an acute angle, it's an acute triangle. Well, that's not true. All triangles have an acute angle. And then an obtuse triangle is a triangle that has one obtuse angle and, again, two acute angles. There is a special type of acute angle. This is a word that may be new to you, so you may want to circle it or highlight it or whatever. This is equiangular. Please notice, just for spelling's sake, that this is not equal angular. There's no L up here at the middle. It's equi, E-Q-U-I is the prefix here, and then angular, obviously meaning angles. So all the angles are the same. If all the angles are the same, it's got to be an acute triangle. It can't be obtuse. It cannot be a right triangle, at least not in our kind of geometry. If you're doing triangles on a sphere, you can actually have a triangle that has three right angles. And if we have time at the end of the lesson, I'll show you what that might look like. So that's how you classify a triangle, by its angles. Acute, right, or obtuse. And if it's acute and all the angles are the same, it's also equiangular. Then by the sides, there's scalene, where none of the sides are the same. Isosceles, where, notice this may be different than what you were taught. The way our book defines it is it says that isosceles means at least two of the sides are congruent. That means that if all three of the sides are congruent, it's not just equilateral, it is also isosceles. And equilateral is three congruent sides. Again, notice the prefix is EQUI. It's the same prefix as it was before. And then lateral means sideways, okay, or to the side. So equilateral, not equal lateral. There's not two L's in the middle of it. And that's where all three sides are congruent. So one of the things you'll have to do on tonight's assignment, it will be a problem like this. We'll give you a diagram and it'll say classify each triangle by its side lengths. So if we're looking at triangle KYR, that's this angle over here, how many sides are marked congruent in that triangle? 2, so it is what? Anyone? It's isosceles, thank you. Then we look at triangle YRA over here on the right side. It doesn't have two sides that are marked congruent, nor does it have all three sides marked congruent. So what kind of a triangle is this? Scalene, thank you, sir. And then the big triangle, triangle KYA, same thing as the last one, it's scalene. We honestly don't talk a lot about scalene triangles, frankly, because they're boring. Isosceles triangles we'll talk about a fair bit, and equilateral and equiangular triangles as well. All right, well, now let's classify these triangles by their angle measures. So triangle JAM, we've got this angle 60, this angle's 80, and this one's pretty obviously acute, right? So all three angles are acute, so this is an acute triangle. Now, if we're looking for triangle AME, the only angle they gave us is 20, but we can figure out the measure of angle AME, this angle right here, because how is it related to the 80? These two angles. Pardon?
Is it linear?
Linear what? Linear pair. What do we know about the angles in a linear pair? They add up to 180. So if we take 180 minus 80, this angle's 100. We don't need to know angle E. We know that this angle is obtuse. The other two have got to be acute. Pardon me. So this is an obtuse triangle. And then triangle JAE, at least judging by the way that it looks, doesn't look like it has any big angles in it. It appears to be at least an acute angle. Or excuse me, an acute triangle. Now, again, those are all terms that you have used before. Again, equilateral and equiangular may be new to you, but the rest of them should be things that you have at least heard before, even if you have forgotten them. The next piece of information that we have is also something that you've known for a very long time, the triangle sum theorem, which says that the sum of the angles of a triangle are 180 degrees, always. So if you measure all the angles, it's 180 degrees. Now, at some point, somebody told you that, but most people have never thought about, well, why is that true? It turns out, and you don't have to draw this, but if I was to fold S down so that this angle is now right here, and fold this one over so that this angle is right here, and fold this side over so that that angle is right there, what do these three angles have to add up to? 180, because they make a straight angle. And those are the three angles of the triangle. You can also do a geometric proof for it. We're not going to take the time to do it, but you could absolutely prove that that's always going to be true. So in any triangle, the angles add up to 180 degrees. The sides don't add up to anything in particular. There is no theorem for the lengths of the sides. Occasionally I get students who try to overgeneralize this. They make the sides of the triangle add up to 180, and that's just not true. So let's use this to find the angle measures in this picture. We're looking for angle RST, R to S to T. That's this angle right here. Remember, when you name an angle, the middle letter is the vertex. The first letter is on one side of the angle, and the other letter is on the other side of the angle. So this is the angle with a vertex at S, where one side goes through R and the other side goes through T. Well, if I look at triangle SRT, I know 2 out of the 3 angles. So they should add together to be 180 when I have all 3. So I'll take 62 plus 40 is 102. And then 180 minus 102 is 78. So it's 78 degrees. Now I want to find the measure of angle SQR. So S to Q to R. Q is the vertex, S is on one side, R is on the other side. I'm looking for this angle right here. There are two very different ways to do this. One way to do it would be to go ahead and find this linear pair right here. 180 minus 62 is 118. So then 118 plus 12 is 130. And 180 minus 130 is 50. The other way that you could have done that is, instead of looking at little triangles, look at the whole big triangle. If everyone will watch this, you don't have to necessarily write it down, but this is what's happening. If I look at this whole big triangle, I already found that this angle is 78. 78 plus 12 is 90, so this whole angle is 90. So I could have done 90 plus 40, which is also 130. Subtracted from 180 gives me 50 that way. Frequently on these problems, there's more than one right way to find the angles that you want. So find whichever ones you can to start with. Don't be concerned, oh, I got to find this one first. If they ask you to find 4 angles, just start finding angles. Okay, don't worry about I have to do this one first and then do this one second. I want you to notice something. What kind of a triangle is this whole big triangle, triangle QST, by its angle measures? How'd you get obtuse? I'm sorry? You have to talk a lot louder for me, I'm sorry. Pardon? In this triangle, angle Q is 50, angle T is 40, and angle S is 90. So what kind of a triangle is it? It's a right triangle. It's got a 90-degree angle. Stetson, you okay? So that's a 90-degree angle, so that's a right triangle. Also notice, what do 50 and 40 add together to be? 90. It turns out that's true in every right triangle. You've got a right angle, and then the other two angles have to add together to be 90 so that you get 180 total. That is something called a corollary. That's a theorem that follows directly from another theorem. This one you don't have to use very often to solve problems, but smarter people use it all the time because it's faster. What it says is that the acute angles in a right triangle are complementary. If you know you have a right triangle, the two acute angles have got to add up to 90. And I have a mistake here. Please change this. It shouldn't be R and T are complementary. It should be angle S and angle T are complementary. So let me show you the example of that. We know that this is a right triangle. So the fastest way to find The measure of angle A is to do just 90 minus 37. It's 53 degrees. Now you can do it by doing the angles of the triangle add up to 180, but it takes longer. You would do 90 plus 37. You don't need to write this down, but let me just show you. This is the long way to do it. That's 127. And 180 minus 127 is 53. You get the same answer. It just takes longer. Okay, any questions about that? Okay, your assignment is in the book. You have a lot of time still left in class. I expect everyone to be working on the assignment. Yes, ma'am.